Hello students, your physics teacher Hassan Darwish with you. In this video, I'm going to apply Ohm's law in electromagnetic induction. Let me start with Ohm's law for a coil first. Let E be the induced EMF in a coil and R the resistance of the coil. And let's orient the coil from N to P. You know that from the previous experiments, in the previous videos, we verified many times that when you move the magnet or when there is a relative motion between the magnet and the coil, then an induced EMF is created in the coil, right? And this induced EMF, here it is, will produce induced current. Okay? In this case, what happened? The coil acts as a generator. Why? Because it produces electricity. It gives electric current. It maintains voltage. Right? Okay. So let's represent this coil in the usual representation of a generator. And here it is, as you learned in grade 9 and grade 10. In reality, in grade 10. This is the equivalent generator of this coil. Okay? Here N, P, P. Why? Because the coil is oriented, as he said, from N to P. What does this mean? It means your four fingers here, as we learned in the previous videos, points like this upward, and here is your thumb. Don't forget this. Okay? So this is a positive sense. Now this is N. Normal to the plane. Right? Okay, good. So the coil is oriented from N to P as you see here. So this representation is the equivalent representation of the generator. Now here we have an external circuit. This external circuit could be a lamp, motor, refrigerator, resistor, anything. Clear? Here's the external circuit. And now we want to apply Ohm's law for a coil, means for a generator, as you studied it in grade 10, okay, in the first secondary. Don't forget this. So Ohm's law for the generator is UPN equal minus RI plus E. You studied this in first secondary. Now I want to interchange N and P, and I want to move in the coil in the positive sense from N to P. Clear? From N to P. So it is Ri minus E. Don't forget this rule. Okay? Let's apply and let's have a direct example about this rule. In this example, we have a resistor here. This is the external circuit. Okay, in the external circuit, we have only a resistor. And this is our coil. The coil is oriented, as you see, in the anti-clockwise. So we have a resistor connected to the terminal of a flat circular coil having 200 loops, number of loops, and of radius 50 centimeters. The total resistance of the coil is R equal 15 ohms. Positive sense, anti-clockwise. Okay, let's apply here the positive sense. You turn the four fingers with your right hand like this. Now the thumb of your right hand will point out of page, means towards you. This is N. Okay? The coil is placed in a uniform magnetic field perpendicular to the plane of the coil and oriented out of page. Out of page means, as I said, towards you, into your eye. Now the magnitude of B varies with time, as you see. If you try to draw B as a function of time, and this could be clearer for you, you will have a straight line of negative slope, right? Means it is decreasing. Determine by applying Lenz's law the sense of induced current in R. Okay, let's do this. As I said in the previous videos when I explained Lenz's law, try to follow 3 steps. Step 1, sense of variation of B. Sense of variation of flux. Since B decreases with time, then the magnetic flux linking the coil decreases. Clear? Step 2, applying Lenz's law. I induced has a tendency to oppose the decrease or the variation of flux. So opposes the decrease of flux. Fine. How it opposes this decrease? By creating, as I said, by creating an induced magnetic field having the same sense. Why? Because phi decreases. Having the same sense as B. Clear? Now you know the sense of B induced. Let's put it here on our figure. So B induced has the same sense as B and the same sense as N. So this is B induced. Clear? Now you know the sense of B induced. We just apply right hand rule. Step 3. Applying the right hand rule. We have B induced out of page, means into your eye, towards you. This vector is towards your eye. Lies your, or the thumb of your right hand, the thumb of your, I'm writing it in detail, okay, in order not to forget, of your right hand, the thumb of your right hand is out of page, means into your eye of page. Now turn the 4 fingers of the right hand. You will see that I induced is anti-clockwise. Okay? Means in the positive sense. Because this is the positive sense. Okay? This is part A. It's very easy. Try to simplify it as much as possible. Now part B. Determine by Faraday's law the induced EMF and the induced current. Okay. Sorry. Part B. What is Faraday's law? The induced EMF is equal to minus derivative of the magnetic flux linking the coil or crossing the coil. Time derivative minus phi prime. But what? But phi equal, is there a rule for the flux? Yes, NB as cosine theta. What is theta? Don't forget theta always the angle between B, not B induced, B, and the normal to the plane, N. Here the angle is, let's look at the figure, the angle between B and N is 0. Why? Because B and N points in the same sense. Okay, good. So let's replace phi equal N, which is 200 loops, and B is minus 0.05 T plus 0.1. This is the expression of B. Now the area of the circle is pi r squared. Cosine, as you said, 0, and cosine 0 is 1. So if you do the calculation carefully, you get minus 7.85t plus 15.7. Okay, the unit is Weber. Of course, you could have made the derivative for the flux from the beginning to obtain the number directly. But I prefer this method. You may understand it easier. So E equal minus derivative of flux 5 prime. So you will get 7.85 volt. Okay? Direct application. Now we want to find I induced. I induced. How much? As we did in the first secondary, we go back to the circuit. We apply Ohm's law for the resistor and Ohm's law for the coil. So Ohm's law for the coil we've just studied it. I'm going to move in the positive sense. UAB, as I said, U and P in the explanation. RI minus E. It's very easy to keep in mind, okay, to learn it. Now, Ohm's law for resistor. You remember Ohm's law for resistor from grade 9 and first secondary. UAB, UBA, right? Look here. You moved from A to B in the coil. Now I want to move from B into A in the resistor, right? Here, I'm moving like this. So UBA is equal RI. But you know that UAB is equal minus UBA. Try to substitute to get I equal E over R plus R. We have everything here. Then if you substitute, you get 0.314 ampere. Okay? Positive number. Part C. Do the results in parts A and B agree? Do they agree? Yes or no? Yes. Yes, agree. Why? In part A, by applying Lenz's law, we obtain I induced as positive number. I induced positive. And in part B, we obtained I positive number. So whether you apply Faraday's law or Lenz's law, you have to get the same answer. Okay? That's enough for this video. Take care. Bye-bye.